Hey, this is Horner, and I just want to show you this is F4 for the simple harmonic motion packet. And we have a box. Here's the box. It has some water in it, and it is connected to a string. And the box is displaced slightly so that it oscillates like a pendulum. So they have this thing here. They kind of pull it over to the side. It's now, like this. Oops, drew a little bit too big, and then it goes back and forth. So it oscillates. It's a pendulum is basically what it is. They want us to calculate the period of this simple pendulum and clearly state any assumptions. So we need to measure from, and I'm going to change color here because I think that's going to be important. Let's go to red. I'm going to start right here, okay? And I want to measure from here down to the center of mass of the pendulum. So you always measure the center of mass. When we did this in the lab, we had the photo gate go through the center of mass, and that helped us calculate the period. So if you have it go from the center of mass down, you'll see that you go from 2 to about 0.5, and if you subtract that, the length of this pendulum is going to be 1.5 meters. Now we're going to plug in that 1.5 meters into L, so T is equal to 2 pi times the square root of 1.5 over 10. And if you do all that math, you're going to get a period of 2.4 seconds. For the next part of this, they have some students, and once again, they're using this whole student thing. In the experiment, a small hole is formed in the bottom of the box just before the box is released to oscillate. Then that water slowly drains out of the box. In experiment 1, when the box is made of steel, the box itself is much more massive than the water inside. The oscillation does not change. When the box is made of plastic, such that the box is much less massive than the water inside, the oscillation period is observed to increase and decrease as the water drains. They want us to tell why in a paragraph. So I would go ahead and do PEE, and I would think about your evidence or your explanation first, then go back and write the P part so you can leave a little bit of space. So we know that that steel box pendulum length is always going to be the same. But if you think about the water, we could say at the very beginning, so this is at T0, this is full of water. At T1, notice that the water is now lower in the box. Let's say that it's half full. Our center of gravity, or center of mass, has changed. So our pendulum goes down to here in the first case, but notice in this case, in time 1, now our pendulum is longer. And if the pendulum is longer, it will take more time for it to swing back and forth. Then what happens eventually is our pendulum becomes empty. And when it becomes empty, then this keeps moving down, 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 and all of a sudden it pops back up again. So at T0 and at T original and T final, it will have the same period because of the pendulum having the same length. Remember, mass does not matter. It's the length of the pendulum. So all that's happening here is we're making the pendulum longer until the water completely runs out, and then this pops back up again. Did you like that sound effect? If that's true, then the steel box never changed in period, but the water-filled plastic box has a changing period. So let's give our evidence here. The steel box pendulum length is always the same. The water-filled box starts at one length, boink, increases length as the water drains, and then goes back to the original length when the box is empty. Since we know that T is equal to 2 pi times the square root of L over G, the steel box period is always the same. And since we know that 2 pi times the square root of L over G, for the plastic box, that period increases, okay, as the length gets longer, as the water drains, and then goes back to the original when that box is now empty because the center of mass pops back up to the middle, and it's the same. So that is really, I like that question. It's a good question. 7-pointer, and that's where you get all your points from.